Okay, so good evening. This is Katuje Caleb, and I'm going to be presenting with my colleague. He'll introduce himself. This is the second assignment in AI, computer science. So with our very first slide here, we are asked to describe the problem we are trying to solve. And this is the problem of text summarization, which is a big part of today's society, considering, for example, you want to summarize some text, like you're doing some revision, but you have a very big textbook and there's a lot of information, but you would like to just get the specific information that you want. So this is a way of doing that. Yeah, so if you look at the next slide, we have the data set, the text summarization data set that we chose for this particular project. Because it provides the feature of extractive summarization. Extractive, there's extractive and abstractive. Extractive, you just get the specific part of the text, and then you just bring it into the final summary. But with abstractive, you get you try to make meaning out of the things that you're summarizing, and those are now what you bring in. But here we shall focus mostly on extractive summarization format. So if you look at the next slide, we have factors that we considered while using this text summarization data set. Number one, we have the project type, which is the summarization of text. Obviously, that is self-explanatory. We have we want to summarize text, and this is the data set that will give us all the features necessary. Then we have the algorithm and model complexity. Because we have numerous data types like text, integers, string, all those, and then because when you have numerous data types, it provides patterns for more interesting patterns in the data when you're trying to sort through the data. Then we have the data set size. It is relatively a large data set size, considering we want to be able to capture a big amount of text and then reduce it down to a smaller size. And then we have explainability. In most cases, it is advisable to choose a kind of data set and a kind of model that will be easy to explain to people, explain the results of how it works, explain the results and how the model works to people. So if you look at the next the next slide, we have the features in the text summarization data set that we are going to use. So these are just a few of them. This is now number one. We have text cleaning. It is the process of preparing raw text for natural language processing so that machines can understand the human language. So text cleaning is just like, it's a way of like decoding, encoding. Yeah, so you're transferring the text, the natural text, the human language text into a language that your computer can understand. So sentence tokenization refers to just breaking down. It breaks down like a given paragraph, for example, into a sentence. And then word tokenization breaks down a sentence into a word. And then word frequency table is just like, okay, it is just a table containing words, the given words in the given text, and then the frequency, the number of times they appear in that particular text. And then summarization, it is the use of deep learning and machine learning models to break down large text into important parts. And now that's just the abstract, the entire meaning of what we're trying to accomplish. So I'll leave it to my colleague to take us to the next part of the presentation.
Yes, good evening, everyone. Yeah, my name is Kakande Abdulatif, and I'm here to present to you Bayes' theorem. So Bayes' theorem basically is a law we all know from our mathematics class. Basically, this was done even during our computer architecture. So Bayes' theorem describes the probability of an event based on the prior knowledge and the conditions that may be relevant to the event. So basically, this is where you have, for example, like an event, like you have, for example, a match going to happen, a football match going to happen. So the conditions are either the match is either won or lost, or the match is won and the other team has not scored. So those are some conditions that you can have there. So Bayes' theorem states that the conditions of a probability of an event on the occurrence of the other event is equal to the likelihood that the second event given that the first event is multiplied by the probability of the first event. This is derived from the formula, which we shall see in our next slide. So the theorem is named after the statistician, the Bayes Anthony, who discovered the formula in 1963. So it is considered the fundamental of the special statistical interfacial approach called the Bayes. So when we look at our formula for Bayes' theorem, so as we said that it's the probability of an event occurring given that the other event occurred, which is equal to the probability that both events occur divided by the event that is given to occur. So that is it for the formula. So then I'm going to talk about the naive Bayes specifier. This is an algorithm used by the Bayes theorem to specify objects. The key insight of the Bayes theorem is that the probability of an event can be adjusted as the new data is introduced. So this means that this probability changes if new data is introduced. So that is what is meant by naive, because the data can be changed as more data is introduced. So we make a naive Bayes classifier. Naive is that its assumption that all attributes of the data point under the consideration of independent to each other. So this means that all data types or attributes being used in this theorem are independent to one another. So the classifier is a single algorithm, but a family of the machine learning algorithms that make the use of statistical independence. So these algorithms are relatively easy to write and run more effectively than more complex Bayes algorithms. So this naive Bayes classifier is basically easier to use than other algorithms that are offered by the Bayes theorem. So it is popularly used in scam filter, text analysis, and medical diagnosizations. So this classifier is used in different aspects of our lives. For example, the scam filters we use in our emails, and the text analysts use this Bayes theorem. And in the diagnosis, remember, we have different conditions that may arise from a medical condition. So we can use Bayes theorem in all those aspects. So the next I'm going to talk about is the Bayesian networks. So this is a probabilistic graphical method for representing knowledge about uncertain domain, where each node corresponds to a random variable and each edge represents the condition probability for a corresponding random variable. So this can be seen in this image down here. So as we said, so in case of this image shown down here, the parents here are the fan, and the fan and the plug. So we also have the children, which is the fan not spinning, and we have two variables, which is a faulty fan and the fan plug, as shown down here. That's basically a representation of the network. So here I'm going to talk about the difference between the theorem and the naive Bayes. So the naive Bayes is a type of prediction model, one that assumes all of the futures that are mutually independent. And the theorem basically is a theorem, and it gives a mathematical result, which I talked about up there. And the theorem allows us to use the probability of a particular model given its observed data. So next I'm going to talk about the difference between the naive Bayes and the networks. So the network assumes all futures that all futures are conditionally independent to one another. So that's what we are talking about, that it assumes conditions, and these conditions are independent to one another. And then the networks don't have any assumptions. They depend on basic information that has been derived from maybe a realistic event that has occurred. So that's why we always draw it with a graph to define the conditions that have occurred to derive the network. So the next, here we have the references that will refer you to where you can get more of the information from this presentation or from what has been presented in this meeting.
Thank you.
So thank you for watching.